Let's draw a Lewis diagram for a free radical. So here we have nitrogen dioxide, and in step 1 we determine the number of valence electrons from the periodic table. So for nitrogen there's 5, and for 2 oxygens we have 2 by 6, which is 12. So that gives 17 valence electrons. And now we draw the skeletal geometry with the least electronegative atom in the middle. So 2 electrons are shared in each bond. So here we subtract 4 electrons. And now we complete the octet of the terminal atoms. So that now leaves us with 1 electron. And we assign that 1 electron to the central atom. And now we calculate the formal charge, which assumes that the electrons are shared equally in each bond. So what we do is just subtract the number of assigned electrons from the number of valence electrons. So oxygen has 6 valence electrons, and we have 7 assigned electrons. So the same thing for this oxygen. And nitrogen has 5 valence electrons, minus 3 assigned electrons, which gives a formal charge of +2. So what we can do here is take 2 valence electrons from oxygen and use them to assign a bond to the nitrogen. And now we'll recalculate the formal charge where the electrons are shared equally between the atoms in the bond. So now the oxygen has a formal charge of 0, and the nitrogen has a formal charge of 1. And this is one of the 2 resonance structures of nitrogen dioxide, because we could have done the same thing to the other oxygen. So you can see there's a limitation to drawing the Lewis dot structure for a free radical which has unpaired electrons. So note that we couldn't assign another bond to nitrogen because nitrogen is in period 2 and it cannot have an expanded octet.